All right, chapter 5 is about topologies and standards. Okay, and we're going to talk about all kinds of different topologies. But I told you way back when we covered chapter 2, I think, that I bring in the wiring for my house. I was finally in my attic and took some pictures. Let me turn the light off for a second. Okay, this is my attic. Okay, I took like 4 or 5 different shots. Basically, got air conditioning ducts everywhere. But this is how all my wiring is done. These are what's called bridle rings. You screw them in. And what I have is this top one is all the cable TV. The next one is all the, well, when I initially installed this was all Cat 6 for Ethernet, for network. This was all Cat 5 for phones. And this was all for internet. Since then, a few things have been added, and that's why there's a couple other colors in there.
What are the drops in the back for?
Oh, and that's for the alarm system. Again, I had nothing to do with that. They come add that after the fact, so I'm kind of like... But what's cool is these go around all my rafters. So you can actually grab a hold of them and just walk around the house. So they're really good to hold on to. But what they do is they come down to each spot, then they go into the wall. So, and I've had it re-insulated. That's why it covers up a lot of it. But
do you recommend doing it like that to prevent crosstalk with the matter?
It's good to prevent crosstalk because they're not near any lights. But I mean, there's 27 drops, but I'm not using all of them at the same time. Okay. So I don't think there's a really big issue with crosstalk. But this is, I mean, even in this room, they're all wired in bunches. Everyone wires them this way. So it's, you want to have all your wiring together. Because like, if I was to wire this room and the wires ran across the lights and everywhere, it's just really hard to manage. But this way, everything's nice and neat. I wired all 27 drops in about 2 hours.
Do you want to avoid like electrical wires?
Yes, avoid. Now, most of your electrical wire is already now is shielded now. They're in metal conduits, so that's not a big issue. Okay. But you want to make sure you don't want to run it down the same hole as your electrical wiring. You just shouldn't. So you drill in the hole next to it or something, and don't go near fluorescent lighting. Now, one bad thing, this wire was put in April, actually probably December 1999. I moved in April 2000. So this wiring is 12 years old. So I'm willing to bet some of that wiring being in an attic is already worthless by now. So if I was going to go start moving it around, it'd probably start deteriorating and breaking. But, 12 years is really pretty good. I was talking to someone, I don't know who it was earlier, about what they do. When I ran this wiring, the walls were up, but there was no sheetrock yet. It was just the studs. And I could drill a hole in the top and drop the wire right down, put a little box on the wall, and have the wire coming out. But then they come after the fact and they put sheetrock on it. The problem is what they do is they lay the sheetrock against the wall, then they cut a hole in it. And they'll cut your wires. So you got to be careful with that. And you'll see some other pictures here in a second. Okay, here's the main area. This is where all the wiring goes down into my pantry area. In my pantry, I have this at the top, plus I also have all my phone and my speakers and all that set up. Now, the bottom ones are speakers. That's what the white ones are. The white wires are speakers. Every room is wired for in-ceiling speakers.
Do you have a bunch of hubs?
What?
Do you have like a bunch of hubs?
Well, the way this, there's one switch in there. I have a 24-port switch. Okay. I have a switch just like this in the pantry that everything connects to. But the speakers also go down in there, and they have, actually at the moment I'm not using them, but they were all plugged into a receiver at one point. So, in one of these wires, I forget which one now, I actually had infrared repeaters throughout the entire house. So you could be in the bedroom and hit play, and they would control whatever. So you could really have one centralized system, like a TiVo system. That all ran out of my office, but it would project to all the TVs in the house because I had splitters and amplifiers and all that. But there's just another view of it. Actually, let me go back to real quick. No, okay, keep going. That's not it. Okay. They basically just go down into the holes in the wall. It's hard to see now because I have my house re-insulated. If you ever want to make your house efficient, I had a company called Weatherization Experts out of Newcastle come out. They charged me $3,000. They basically put soffit blocks on all my soffits, if you know what a soffit is, and insulated it. I mean, my air conditioning system's in the middle of my attic, and it was all plywood around it. Well, there was no insulation above that, underneath that. They rip all that out. They actually build up the floor. Now I get a nice walkway, and it's Very professional job. So my utility bills, I paid, now again I have solar now, but it went from $400 and something to $120 this year. So in the middle of the summer. Alright. I had the air conditioning replaced, is why there's another wire there. But the lines just drop down to all the different locations. So they drop down here, they drop down over there. And this here, no, that's still not it. Yeah, that's, okay. But what I also have, which I thought I had a picture of, but you can't see, I have a central vacuum system. You know what a central vacuum system? I have a unit in my garage, a big old system, that when I vacuum, it all goes into it. Then I have outlets throughout the house. Then I have a vacuum hose. I just plug into the wall, turn it on, and vacuum, and it all goes out into the garage. And it takes no bag, so I have never replaced a vacuum bag in 12 years. And it's great. Absolutely. And it's got a 35, the hose that comes with is 35 feet long. So all you got to do is measure the farthest point and make sure wherever you put it, it'll reach for all the rooms around it. And since it's in the garage, it's great for vacuuming out the cars. You just plug in, you can vacuum your cars out, you can vacuum everything. It's wonderful. I got that installed, and yeah, I use it all the time. I absolutely love it. So central vacuum system. But I installed all the wiring and the central vacuum in 2 hours. Because it's just like that PVC pipe. It's just like that. And you just put them all together, and again, there was no walls in at that point, so we literally could stand in the middle of the room with the ladder and just run it, and it was super easy to do. So, but these slides are up there if you want to look at it. They're under content. It says Chapter 5, edited by Ken Picks, or whatever I put on there. So, but they're in there. So that's what my attic looks like. And everybody ever comes out and looks at it. When Cox came in to install my first T1, they're like, "Oh my God!" And they were thrilled to death because it was all wired. They could just jumper the wires in the closet and then instantly connected the outside to the correct port in the room and made it a lot easier for them. So it's kind of handy. So if you're ever doing something, I recommend doing this ahead of time. And like he's getting ready to do his, wiring's cheap, $100 for 1,000 feet. So yeah, we just did it in no time. I wouldn't install as much as I did. See, every jack has a coax for television, a Cat 6 for the network, a Cat 5 for telephone, and then yeah, that's what I have to each one of them. What?
Then internet.
Yeah, the Cat 6 was for the internet.
Did you get the modular jacks where they were 3 stacked on one?
No, I actually got 4-port plates for each one. So it has coax, telephone, internet. Is there a blank on one of them? But I also got infrared going through all of them and stuff. In some of the areas, like in my garage, I actually had 4 jacks put in, all in one outlet, because I was originally going to put a workbench out there. And I wanted so I could plug a bunch of computers in. And I even got jacks in the laundry room. And the funny thing was, I didn't put anything in my closets. And that's the one place where I kind of wish. I mean, now I don't have phones, but it would have been nice years ago when I had a home phone to have one installed in the closet or in the bathroom, but no, to put one there. But nice to have. So you're in the bathroom, man. You got to talk on the phone.
I had one of those.
Yeah. Oh, and in my living room, I have 3 big, huge windows. My whole back wall is windows. And I wanted a jack right in the bottom of it, underneath the window in the center. So I ran conduit. You can't see it, but well, let me make sure you can. Okay, now you can't see it there. But in the back, against all the outer walls, I have what's called Smurf tubing, which is blue flexible pipe. And you basically run it from your attic to the wall jack. And then you can put wire in and out of it. So up in my attic, above my main windows, I have a tubing way up in the corner, and it goes down the wall, all the way across the bottom, out that jack. And I've replaced that wire like twice. So I've taken out the RG6, I put in shielded Cat 5, then I've taken that out and put in more Cat 6 in there, so I've replaced it multiple times. So you can very easily do that with that tubing. That's the one I want to get rid of. Hold on. In 4 hours. Yeah. Okay. So, yeah, kind of good. And when you're doing stuff like that, they have this called cable goo, cable something. It's a big container, or you can get it in 5-gallon buckets. It's really slick.
Wire lubricant.
Wire lubricant is what it is. It's like, it's water-based, but you take it in handfuls and gob it on your wire and stick it down those conduits. Because even the one going down the wall and all the way across and out, I was able to slide the cable in and out perfectly. So, and I also got cabling, which is actually right over in the corner there. I have cabling that goes down and outside my house to my back building, because I have a shed in my backyard and where my servers were. So I have intercom run out there and telephone and Cat5 all run out to those buildings as well. So it's all on this wiring here, and it's kind of handy. So that's what I told you I'd show you that someday, and I finally took a picture. They were up there checking my heater out the other day, and I was like, ooh, hold on. All right, any questions? Okay. All right, so let's talk about some different topologies, okay? The physical topology is the layout. How are we going to do this? What I did with my house is I took the blueprint of my house, which you can get off Zillow or anywhere. I took it to Synergy Datacom, which is a radio supply, Synergy down on Classen and 4th, I think, down. If you've never been there, good. I think it's what Friday do they have free food there, do you know?
I haven't been there forever.
They don't do that anymore? Oh, you haven't been
No,
there?
I haven't been
Okay.
there forever.
They have free food. It's like the second Friday or the fourth Friday, and it's always put on by a vendor like Leviton or Belkin or something. So it has hamburgers and hot dogs. But I used to know the co-owner of the company, Jim Nasher. So I took my stuff there and brought it, and we actually sat and come up with a plan on how to do this. Then we figured out how much wire to buy. Kind of like you all did for that project is exactly what I did for my house. That was nice, because when I did the job, I actually had plenty, but not too much. I think I got like a half a box of stereo wires still, because they came in 1,000 feet, and I didn't need that much. But so I came up with a plan for doing it, and I actually went and did it. And what was nice about Jim was he let me borrow all the crimpers and stuff. The RG6 crimpers are expensive. And Jim, I said, I'll just buy them. He goes, hell no, because just use ours. Yeah, he said, just borrow ours. So he let me borrow them, and he goes, when you're done, bring them back. So I used them for a weekend and brought them back. So kind of handy. All right. So they talk about the broad scope. Basically, how are you going to lay this out? You don't necessarily have to worry about the devices or how they're being connected, but how are you going to basically lay it out? That's what I did with him. Where are the wires going to go? They're all going to come here. Don't worry about connecting at this point, okay? All right. So you don't talk about, just like you guys did. How are we going to basically run it? You guys didn't really get into exactly how many connectors and how many computers and stuff. We just want to get the wiring in place, okay? We could go in bus, ring, star, or a hybrid. So what would you consider my house is? If all the wires come into one central place, what would it be?
Star bus, I guess. But
Well, it's really a star, but considering it goes out to another building with other, it could be a hybrid, but it's mainly a star. Okay? And let's talk about each one of these. Okay, a bus. It's a single cable. It's only one cable that goes from computer to computer. No one really does that anymore, with exception of high-speed backbones. Like on the campus here, they have a piece of fiber connecting all the buildings. That's a bus. Okay? Connects all the nodes, no intervening devices. It's basically just not used except for backbones anymore. Okay? Right? Normally done with coax, but now can also be done with fiber. So the connectivity medium is always changing. Okay? All right, passive says nodes listen for accept data, use broadcast to send data. A lot of them pretty much do that now anyway. Okay? I think they actually have a picture here in a minute. Okay? With a bus, they're going to show us our connectors. 50 ohm resistors, stop signal at the end of the wire. What they're talking about there is if the wire starts from Lucas to Daniel to Bobby and around the room, you got to have a cap on each end of the wire. Think of it like a garden hose. I mean, you got to have a cap on it. So that's what that does. Okay? The signal bounces from end to end, and the terminators on the end basically absorb it. That's what these are. They absorb it to prevent it bouncing back into.
did that with like fire alarms set up.
Mm-hmm.
Did
Yep.
that with SCSI.
Yeah, SCSI devices do that too. Okay, and yeah, all right. One end's grounded, removing static electricity, so on and so forth. Okay, and here's our picture. We got our bus topology. We have our terminator on each end. So what'll happen is when this computer here talks, he sends a signal out to the cable that goes both ways. Reaches all the computers on the network, and then these terminators at both ends kind of absorb it. Because you don't want it to bounce back and forth. It's not a good thing. Okay? It's not normally used anymore, but it is still out there. Okay. Advantages, relatively inexpensive. No hubs are required. No switches, because it just goes computer to computer. We're basically connecting each computer. And originally, Rose State, we had that here. Okay. Disadvantages, doesn't scale well. If I want 10 computers, no problem. If I want 200 computers, it's not going to work. Can you imagine me running that in my house to each outlet and then go back up? That would have sucked. It'd be terrible. Difficult to troubleshoot. So if we had a bus in this room, then all of a sudden we lost connectivity. Where's the problem? We don't know. What? Exactly. Because, I mean, if there's a break over there, okay, there's a break. We just won't know that because none of us are going to work. We'll have very intermittent connectivity. So, very hard to troubleshoot. Okay? Not very fault tolerant. Cable gets broken in one place, you're done. Like, at least with this star, if I was to unplug one wire, what would happen?
Just one computer.
One of you would be off. Unless I happen to unplug 24.
Yeah.
But then, while instantly everybody goes off, then you'd know. So if everybody went off, would I be checking Daniel's wire? Probably not. I'd be checking the main wire. So it's a lot easier to troubleshoot. All right. Ring. Okay. Nodes connected to nearest two nodes. It's in a circular format. We'll see a picture of it. It goes clockwise. But they also have dual rotating rings where it can go clockwise and counterclockwise. Okay. It's active. What happens is the signal goes from Lucas to Daniel. He looks at it. Is it for me? Yes or no? And he sends it on. He basically, they call it token ring. They have a token. Okay. All right. It's active, so each one works with it. It stops at the destination. So once, if Lucas is trying to talk to Bobby, he sends it. Daniel gets it. Nope, it's not for me. He sends it on. Bobby gets it. Oh, it was for me. Then she removes it from the network. Then she puts the token back out there. Okay. Could be done with fiber optic or twisted pair. All right. Drawbacks. A malfunction workstation can kill it. So one computer could screw up and kill the entire thing. Because if we're going in a ring, say Bobby's computer screwing up, guess what? We're done because nothing's going to get past Bobby's computer. Okay? So that's a big drawback. Okay? And I've seen it where, you just get one computer that screws up stuff. Some of you worked on networks before, sometimes there could be one computer sending out tons of traffic. Like you look at your switches, I don't know if you've ever seen these, but they're blinking right now. Sometimes, if you're having problems, you see them where they're basically solid, they're blinking so much. Then something's going on the network causing an issue. Okay? Not very flexible because you're limited on what you could have normally. Depending on the system, you're limited to like 256. They used to have one called, it was ArcNet. Anyone ever worked with ArcNet? ArcNet, that was actually what was installed in Building 3001 at Tinker. I helped install that years ago. You're limited to 256 computers, that's it. Nothing beyond that. Because each one basically had a node number. And you're limited, 256, that's what you're limited to. All right, star. It says nodes connect to a central device like we have here. Okay, a router or a switch or a hub or whatever. Okay, could be twisted pair, could be fiber. Okay. All right, single cable connects only two devices. Basically, the cable goes from the switch to the computer. So each one of you has a direct connection to the switch up here. Okay? Advantage is very fault tolerant. So if one of you gets screwed up, it only affects you. It doesn't affect everybody else. Very flexible. Can you keep adding more? Okay? It's most popular. That's what we all pretty much use now. Okay? Do you see any, now they say 1,024 addressable logical network nodes. It's not necessarily true because you can go more than that. But does anyone see a problem with this? Is it fault tolerant at all? It is somewhat.
Switch goes down.
Right. We still have a single point of failure. So if Daniel's wire screws up, Daniel's off. No big problem. But if the switch goes out, everybody goes out. When I worked for Sergeant Grit Marine Specialty across town, initially he was real big on saving money. I mean, it was a very small company. As he started to grow, we actually had a switch go out one day. I'm like, crap. So we went out and bought another switch. Then I finally talked him into buying a second switch as a spare. So we were great. The next time he had a problem, guess what? It took out two. Then he's like, darn it, we should have had two spares. I'm like, yeah, but, what are you going to keep? 27 spares? There has to become a point where, and especially with technology nowadays, you really want to buy a bunch of stuff today when you know next week it's going to be new? But what, the iPad mini came out today? Anyone order that yet? I'm not going to buy it. I have the iPad Maxi. It's pretty handy. So, one of my students who works for Apple says, "Oh, you can buy one." I'm like, "Dude, I'm getting old. I have a hard time reading that small font. That's why I got the iPad maxi size, so I can read the darn thing." Did y'all? And somebody on an iPhone? Did you know if you click it 3 times, it makes the screen larger? If you didn't know that, pretty handy, especially for us blind people. Works great. But so this is the start, most popular.
Actually, you do it 4 times, you do it in 3D, doesn't it?
Is this what? 4 times like 2 twice? No.
Right.
All right, hybrid. Okay, pure ring bus star. There's really none out there. Because even here, we have a star in this room. But this star is connected to a central area. So we really have a bus star topology. Okay? So we really have a bunch of it put together. Okay? A bunch of different ways you could do it, which they're going to show us. You could have a star wired like a ring. Actually, rings are normally wired like a star, by the way. Even though I showed you a token ring, it's normally wired by like a star. What happens is this switch is replaced with a concentrator. And it sends a signal out on wire 1. It sends a signal out on wire 2, then wire 3. So even though it's a ring, it's wired like a star. So you're not going to find... can you imagine if we actually had a token ring network, all the computers in a circle? It's not going to happen. It's not, okay? Benefits, we get some topology, we get some fault tolerance because of it, and there's token ring, we talked about that. Anyone know how to remember that? How to remember 802.5? 5 golden rings? Easy, 802.5, 5 golden rings, token ring.
5 dwarven lords of token.
Yeah. The Lords of Leaping, whatever? Okay. And there's our star wired ring. We have a switch or whatever, a concentrator in the middle, and it goes out to each one. It's really a star. It's really a ring, but it's wired like a star. Okay? So it goes out on one, then out to the next, and out to the next, but it functions as a ring. Okay? All right, we have star wired bus. Workstation and groups are connected with star connected devices, but that's pretty much kind of like we have here. Even at Rose State, we have a bus between the buildings, but each building has a star, so it's really a star bus topology. Okay? Advantages, covers longer distances, easily connect, isolate different signals. We actually had a meeting today, by the way. He gave the wrong figures, but he was saying that our network here, he says our wireless is currently 100 meg. It's not, it's only 10 meg, but it's been increased tenfold. So the wireless will be upgraded very shortly to 100 meg, in case you're wondering. So we're working on that. So that was one of my multiple meetings today. Okay. Drawbacks to this, again, we have cabling. So this type of wiring here, did we waste cabling by doing a star in this room? If we had a bus, remember, go from Lucas to Daniel to Bobby and around. But with this way, remember, they're all run around this way. So basically, for Lucas, I went all the way down over into Lucas. Now, all the way down to Daniel. So basically, these wires get very long. Are we wasting wire? Yeah, but the wire is cheap. It's very, cheap. Okay? All right. So, yeah, again, it could be basically expensive. Okay? It's not because they're cheap. Okay? There's a star wire bus. We have our 2 switches. So you can think of this as 2 different rooms or 2 different buildings, all connected by one piece of cable. That's what we have here. In room 201, we have a switch. That switch goes to room 211, to 214, to 221. It goes to all the different rooms. Then that switch connects out to the internet.
How many can you have?
You're really only supposed to have 5. You can have more than that. It's one of those deals like the speed limit is 70. Does that mean you can't drive 75? You can. Will you always get away with it? No. But same here, you're supposed to go with 5. If you go with no more than 5, it's going to work. If you go with 6, will it work? Yeah. But will it always work 100%? Possibly not. See, the problem is when you have too many of them, it's kind of like, remember the telephone game when you were a kid? I tell him something, then he tells it. Sooner or later, you lose the signal. Same way, with too many switches, it could take too long to get from point A to point Z. And our signals, you have to reply back in so long, or else it's kind of like calling a phone. You ever call somebody, hello, hello, and you hang up? Well, how long should you wait? The same with the electrical signal. How long before it repeats the signal? Because if these were 5 apart, or 6 apart, or 10 apart, this guy might transmit something. By the time it gets to this guy, it might be such a long delay that this guy thinks it never makes it and sends it again. So really 5 is the max you're supposed to have. I've done it with a lot more than that. I think I've done like 8 before. But if the different switches only have one, I've actually used this because you're limited to 300 feet. I've done one, from one switch, as far as I possibly could, basically 300 feet, put another switch. Then from that switch to another switch for another 300 feet. Then from that switch into another building for another 300 feet. So I was basically going way over 1,000 feet. And it actually worked. But the switches really only had one connector on them. It's not like they each had 20 computers coming off. They only had one. And it worked. And the company really wanted to connect these 2 buildings without having to run a new wire, a new internet service for the other building. It's kind of like the Cox Center. The Cox Center, it's still called the Cox Center, isn't it? And then the Chesapeake Arena, they're all connected together. They're connected to an underground tunnel. And originally, the Chesapeake Arena was not there. That's an afterthought. So they said, hey, can we just connect them so they're actually connected together now? So the Chesapeake does not have its own internet service. So. All right. Logical topologies refers to the way it transmits between nodes. Rather than the physical layout, how does it actually work is what we're talking about here. Okay? All right. Bus and ring are what we normally see. Okay? And the broadcast, this is all the nodes connected to it. In other words, when you have a broadcast signal like we looked with Wireshark, who receives it? Okay? Excuse me. We all have Cox, I'm assuming, at home. Take your laptop, and between your cable modem and your router, I'm assuming most of us have a router, like a Linksys or something. Unplug it. Go from your cable modem directly into your laptop, and run Wireshark. You'll be amazed at how much traffic you get, because cable network is actually a broadcast domain. Cable is a shared medium, so everybody in your neighborhood is sharing the same wire. So that means if you go between your cable modem and your router, if you put a laptop in the middle there, you're going to see all the traffic from all your neighbors. Kind of like when we turned on Wireshark here, we saw a bunch of broadcast traffic. You'll see all the traffic from all the broadcast traffic from your neighbors. It's kind of scary that you can't. But, I actually have a capture of that. Maybe if I can find it, I'll show it to you. But it's just amazing. You'll be seeing all their computer names and everything for your whole entire neighborhood.
That makes it really vulnerable.
Yeah, but again, it's only the broadcast traffic, so it's it's basically all the things saying, "Hey, I'm Ken Dewey's computer, and I'm sitting over here." You're not really seeing their internet traffic, but you're seeing just like when we turn on Wireshark. Actually, let me show you that. If I bring up Wireshark, where's my mouse? Oh, Wireshark. So if you do this at your house, if you plug your laptop straight into your cable modem, capture interfaces. Okay. I am doing nothing right now on the computer other than showing a presentation. You see all this other traffic? This is what's called broadcast traffic. This is computers just saying, hey, I'm over here, or hey, where's so-and-so? It's DNS requests, it's DHCP. It's SSDP from the routers. It's just all kinds of different stuff. Reversed ARP traffic, UDP stuff. So this is what's called broadcast traffic. This is traffic that's just out there. Do this and you see all the traffic from all your neighborhood computers. So
with the broadcast traffic, couldn't you take that to use as a man-in-the-middle attack?
yes, you can. Because let me stop this here. All right, so I stopped it right here. We're already figuring out some MAC addresses. We're already saying, who is this guy? Tell this guy. So we already know the IP addresses on the network. We know some of the MAC addresses on the network. We know some of the ports that are being opened. We know the source and destination ports. So there's just, you can find out a lot of information. It's kind of like someone just sitting there listening. If you just you ever go into a room where people are talking? And you can just, I was on the cruise ship this last week. We were playing Disney trivia. And when we didn't know the answer, all you had to do was be really quiet. Because there was different tables of people doing it. If you listen, you could always hear, oh, that's such and such. What? Thank you. Write it down. Kind of what it was doing. They were broadcasting the answers too loud, and we were hearing it. So, yeah, do that and you'll see all your neighborhood computers. And
Where did the broadcast from? I mean, you got all that information going to the neighborhood. Where is it coming from?
It's coming from each computer in your neighborhood. So your computer in your neighborhood is sending this stuff out. And picture it. Okay, Cox has a switch in your neighborhood. And all the different houses in the neighborhood all connected to that switch. So inside your neighborhood, all this type of stuff. Who belongs to this? Who's in charge of this?
So it all communicate together?
Right, all across your neighborhood. And majority of it your computer ignores because it's getting to your router and it's saying, oh, that's not for me, and it doesn't answer it. But it's still there. Okay? So yeah, if you take your cable modem, plug it straight into your laptop, and refresh ipconfig/release renew and get a new address, and just listen.
You got to do it, take one and just ping it?
Yeah, you should be able to ping them. Like I could right now ping all these guys and they'd be on. So that's why a lot of people say, oh, I don't have a firewall running. Like in my principal's class, they had a project telling me about the firewalls they're running. So many people say, I don't have a firewall. Well, now since I'm plugged in through a Linksys router, I kind of have a hardware firewall. But what if you didn't? What if you actually had a laptop plugged straight into a cable modem? Then you're live on the internet. If you don't have a firewall on your laptop, then not everybody has a router. So it's kind of scary stuff. Okay. So they basically connect to a repeater, a switch of some sort. And my neighborhood, my internet there is only about 3 years old. All brand new wiring, so it's really good and really fast. But I'm assuming some of you have in places that the cable's been there for years and years. Probably have issues with it. So it really depends. And sometimes they expand them so there could be more people on your broadcast domain. But I haven't looked at mine in a while. The last time I looked at mine, I was having an issue with my internet. It was being too slow. And the guy's like, oh, I know what the problem is. You got a router. Like, so? That's slowing your internet down. You need to get rid of that. Like, well, but it was one of those deals I called Cox, and you have to go through level 1, get to level 2 before you get to actually someone who can help you. I said, dude, the router's not the problem. Oh, yes, it is. I guarantee you that's the problem. And finally, he wouldn't do nothing until I plugged it directly into my laptop. So I went in, jumped the wires, plugged it straight into my laptop. And he's like, so how's it working now? I said, it still sucks. Then he's like, are you running in safe mode? I'm like, no. He goes, oh, that's why. You need to be running in safe mode.
What?
Yeah, exactly. I have to be running. I had to turn off my firewall. And I have to be running in safe mode without a router. That's the only way to get it to work. I'm like, dude, you're an idiot. But
You immediately asked for a supervisor as soon as you
well,
did that.
this was the level 2 guy. And what sucks was they I figured what the problem was the cable modem itself was screwing up. But they kept saying, no, the cable modem's looking good. It's looking good. But I remember when they installed it and it wouldn't work. So the guy went out, he opened a brand new box and it wouldn't work. So he went out to his truck and grabbed him out of the back of his truck. And it worked. But it was an old one. So they were going to schedule a service call. I scheduled it for like 2 days later. I went to Best Buy and bought one of the real nice, was it DC3, the new technology for cable modems? Man, it was awesome because they kept upping my speed. I bought like the 20 meg connection. They kept upping it, but it wasn't helping. So I went and bought the new cable. I have a 100 meg connection. I had that for months and months actually before they finally realized and lowered it back down to 20. I think I have 30 now, but pretty funny. But no, sometimes you just have to go with what they say. But no, while I was like that, I brought up Wireshark and I could just see the whole neighborhood on there, and kind of crazy. All right, backbone networks. This is cable connecting hub switches and routers, kind of like we have here. It's between the building and the row state. More throughput, they're usually larger. Used for large, normal like fiber optics like we have here. Could I run fiber optic to every computer in this building?
That's expensive.
Sure, I could. It'd be very expensive, but it'd be very fast. And do I really need it? 100 megabits? I mean, come on.
Sure you do.
Yeah, it'd be nice if I had it. But, I'm assuming some of you have Netflix and stuff. Can you watch, like, Netflix on 2 or 3 different devices in your house? Yeah, I've had no problem. And I figure that's probably plenty of bandwidth for me. It's... I found out my son. Didn't I tell you my son upgraded his service recently? Didn't I tell this class? Well, he upgraded to the, whatever, at Cox, the super heavy-duty service. I found out he actually rents out storage space from some company in Russia. Yeah, he basically said, I guess they block a lot of stuff, so they basically come in through him and go out, and like, oh, that's nice. So, and he was like, yeah, but we can't watch Netflix, play WoW, and on 6 machines at one time. I'm like, whatever.
Wait, I know
He said a Russian
So is he
company
like a
rents,
proxy server for
Some
that?
Russian company said, yeah.
paying him to go through his network.
Yeah.
That's safe.
Yeah, I was really pleased with that. All right. But we have fiber optic backbones that could be Cat 5, like we have here. Okay. Enterprise level, they are more difficult to set up. We're actually talking about the wireless in the meeting today. And I don't know if you know how Rose State Wireless is set up, but it's basically free. You just connect to it. It's really as a courtesy network. It's not really supposed to be used for enterprise level or even business use. Problem is we are using it now. A lot of instructors use it, and a lot of students are using it. So we're getting ready to upgrade ours to another level that's going to be a lot more complex and it'll be a lot faster, and hopefully by January that's going to happen. So we're also looking, I'm going to be on the committee to replace our email, our student email. Okay, guess how much you think we pay per year for student email? For the whole campus. Just for
student or all together?
Just students.
$5,000.
$64,000. We pay 25 cents per student per month. And with the current enrollment, we're paying I just saw the bill today, $64,000. Now I've been telling for years, dude, Google, Microsoft, Hotmail, somebody. So they finally decided to look into it. Because come on, $64,000. The entire budget for this building, all the business division, was only $84,000. No, $88,000. So for all the new computers and all the new Macs and everything we got, we're paying $64,000 for student. Isn't that kind of a waste of money? So I think they're finally going to look into that.
ITT does Hotmail.
Yeah, so many of them do. I teach at Park University. They're worldwide. They use Gmail for faculty and student. Because it never goes down. I mean, it's awesome. All right. But enterprise level stuff can get difficult to set up, especially when some places are remote. Like we have an office at Tinker Air Force Base. When I first went to school here back in the mid-90s, they actually had a dedicated ISDN connection to Rose State. From here to the Tinker office. That was expensive. Now we don't. Now most places just have an internet connection with a VPN, and we're good to go. And I set up a network between Chapel Supply, they sell pressure washer equipment. I set up from their Oklahoma City office, which is over on Meridian and Reno, to their Fort Worth office. And when they asked me how they were going to do that, I'm like, dude, you're going to buy internet service at both locations. They're just going to buy 2 VPN routers. So I bought, Dell just bought them out, begins with S, not SpeedStream. It was a brand of router, I can't remember the heck name. But whatever it was super easy to set up. Because I configured one here, installed it, configured the second one in the same place, got it all set up. So here, take this to Texas and just plug it in and it'll work. And they're like, are you sure? Sure enough, it worked like a champ. So they immediately have a direct connection now through the internet. So it works really good. But they can be complex to set up. Can't think of the name now. Oh well. But so enterprise could be your entire organization, could be special buildings. The Turner Turnpike. Pike Pass, anyone ever use the Pike Pass? That's actually housed out of Tulsa. Whenever you drive through one of those sensors, it actually sends your RFID signal from your car all the way to the server up in Tulsa. It checks your account balance, and it comes back and either says, Pike Pass, thank you, or account balance low. Has anyone ever seen that? It actually does. It's real-time checking your balance, so kind of cool. So, really nice. And, yeah. The guy who taught me networks way back when helped install that. George Floyd works at OSF right now. He helped install that.
I was just thinking, you could do packet captures near those stations and pick up a lot of...
I could go out in the parking lot.
Yeah.
If I had a Pike Pass receiver, walk next to your car, then reprogram another one.
Reader, right?
Yeah, the
What?
RFID
Yeah, just an RFID reader. Walk near your car,
Yeah.
figure out what your signal is, reprogram another one, and be using it. But they do take pictures as well, so they could sooner or later possibly catch you. But
They only take pictures when your account's 0, right?
So I've actually gone through sometimes where it hasn't worked. And I've never gotten a bill. I mean, never got in trouble or anything. I'm assuming they at that point look at your license plate and see that you actually have one and see that there was an issue with the system. But I don't know. But it's nice. I like it. It's cheap. Okay. So serial backbone says simplest, basically just 2 connectivity devices. Use something in a daisy chain format. Okay. Link serial devices, and I think we have a picture of this in a second. Very easy to grow. You just one, then you add another, and you add another, and you add another. Okay. Low cost, and that's pretty much what we do here. We got one switch, connect to another, and so on, I think. Okay, there it is. There's our picture. Okay. So we could have a router with a switch and a switch and a switch. So we could have computers off of each one of these switches. But you're limited from here to there between the router and switch 1 to 300 feet. Then switch 1 to switch 2 to 300 feet. And switch 2 to switch 3 for 300 feet. So we're talking 1,000 feet already.
And you're talking about just based on the cabling that's using it.
Right. I mean, that's the maximum you can have. So the one I set up for TerraValve Technologies, I connected TerraValve Technologies to rupture pin. They were the same, owned by the same company, 2 different buildings. I basically connected them, switch to switch. It was basically from the main point to a switch, then through a conduit into the other building to another switch, then all the other computers' connections off of that. So, but now internet's cheap. So. All right. Says you're limited the number of devices and how the distance between, like I said, 300 feet. Now, if you go with fiber, your distance is different. You can go longer distances. Okay. Figure out how many you can have. Like I said 5. I think they're going to show us in a second. 5 is the max. To exceed the standards, in other words, if your cable's too long or too many switches, it's going to be intermittent. It'll work. Like when I first took care of St. Philip Neri network right over here, the one you guys did part of the wiring for, the network was very slow. And when I was told about how it was set up, it turns out it wasn't set up that way. So I had to walk around with a bunch of students, and we actually were checking it all out. And I was up in the library, and the second floor, I think we said computer lab, where we all wired it, and there was a connection in the wall. It was coming from a switch to the connection in the wall. I'm like, what's this for? And I'm like, I don't know. I unplugged it. Instantly, the network started working so much better, because what it did, it actually created a loop. It's like if I took one of these wires from the switch back into the switch. It'll still work, but it causes issues on the network. It's like packets kind of get lost talking to itself.
You got like a bunch of trash floating around.
Exactly. Because I asked them, what's this for? They're like, I don't know, but we were told don't ever unplug that. I'm like, well, let's unplug it. So we unplugged it, and sure enough, fixed everything. We ended up tracking it down. What they had done was they went from the north building, did all those stuff up there. They went to the south building, then went upstairs, then went from upstairs back to the north building. So once I unplugged that wire, then everything was working perfectly. So, but again, there's so many people, different people working on it. So you never know. Okay. All right. Not used in modern networks today. No picture of it? Okay, they don't have a picture of it, sorry. Okay. Distributed backbone is connective hierarchy to central connectivity devices. It's just basically how to connect stuff together. Okay. Simply can add more connectivity devices to it. Okay? And what's nice about this is you only have to worry about, like, okay, could Rose State add another building? Sure. They could add another building with all the switch internal to the building and then just connect it to the backbone for the rest of the campus. Okay? Okay? Okay, it can be complicated as well. Okay, it can take the, like we have routers connecting ours. Okay? You could have workgroup segregation. We actually have the, like, a lot of this traffic inside the business building stays inside the business building. Like, we image computers all the time in here. When we're imaging computers in this building, do we really need to be, does that traffic really need to leave this building? No. So it keeps it, basically segregated to our area. Okay? Okay. We'll watch for your length, and you could have a single point of failure. Like if the fiber between us and the Fine Arts building goes out right now, we lose our internet. We still talk internal, but we can't get outside. Like, did I ever tell you where the internet comes into this building at, or into this campus at? To the humanities building. That's where the main wire coming into the building is humanities. But we got new cable already. It's already been run down all the way down 15th Street to the communications center, and it's sitting, you know where admissions is? If you walk out of the west end of the admissions building, there's like some picnic tables there. And then there's a phone pole out there. The new cable or new high-speed internet is sitting at that cable, sitting at that phone pole. They can't connect it to the building because it looks like they poured that concrete slab over the junction box for the cable. So I don't know. They're going to have to somehow track it down, and so soon our internet will be changing.
Hire some gophers.
Yeah. Well, they're like, "How are we going to find it?" I said, "Dude, you're going to have to hire Cox or somebody because it's not good." All right. And here we go. Look at that. We have a router, all kinds of switches, and this is, it might look confusing, This is basically what we have. Like that router could be our connection to one net. Then that goes to all the different buildings. And in each building, inside this building, we have 2 routers. We actually have 2 different set nets, 101050 and 101060. So it can get more confusing. And that's actually a little bit over the limit. But let's see if they tell us the limit. And here's another one. Connecting multiple networks together. Okay. Collapsible says use router, switch, single centralized connection. There's really nothing new. And they're kind of talking about like that. If that router goes away, we're pretty much dead. That's kind of what they're talking about here. You can have a single point of failure right here. It says routers may slow data transmission, and an example of something like this is Terry Byers used to take care of a CAD design company. You know what CAD is? Computer-aided drafting or computer-aided design, I guess. And they worked with files that were multiple gigabytes in size. They were stored on a centralized server. So anytime one of the workstations opened them, they were actually transferring gigabytes of data. So having multiple routers can slow you down. So what Terry ended up doing in that place was moving the server. It's kind of like moving the server. If all of us were the CAD designers, we moved the server into this internal network so it didn't interfere with everybody else. So it can make stuff a little confusing. So here's our main router connecting to 2 different networks. Okay. Could you connect them both together? Well, you could, but then they'd be on the same network. Normally you want them separated by different networks. Actually, here we do have different networks, but they all kind of work the same. Okay. Parallel, most robust, says more than one central connectivity device in case stuff fails. Okay. You have duplicate connections. So how many of you have 2 internet services at your house? Nobody does. But if you really needed internet 24/7, I mean, really had to have it, would having coax cable be a good choice? For one connection, but I mean, would that be your only one? Sergeant Grit Marine Specialties, he sells thousands and thousands of orders per day over the internet. We're talking hundreds, millions of dollars. So each hour he's down, he could be losing tens of thousands of dollars. So what he has Cox Fiber for his main connection, a 5 gigabyte connection, I think. Then he has Southwestern Bell. I think they're DSL or something. I forget exactly what they have for them. As a secondary connection. Not as fast, but it still works. So that's kind of what we're talking about here. You have redundancy, you have increased performance, better fault tolerance. Think about Google. Google has, remember we did the round robin, we did NS lookup, you saw a bunch of servers? Can you imagine if everybody in the world hit the same Google server? We'll be done. And whenever you use a app for your phone called Waze, W-A-Z-E, if you don't have it for your cell phone, you need to get it. It's free, by the way. Works on Android and iPhone. W-A-Z-E. Okay? What it is a mapping software. It's like GPS, turn-by-turn navigation. But the cool thing about it is if you run it, it actually tells everybody else your speed. So if you're driving on the highway and there's others on the highway and they start slowing down, instantly you notice the traffic up ahead is slowing down. And you can very easily post if there's cops. I used it all the way to Houston and back, and it was really amazing. You can find out exactly where the accidents were, and it's totally free. And it's user-supported. 100% user-supported. And what's cool is that's the only mapping I've seen that actually has the correct I-40 on it. Now, I-40 recently moved. Since it's 100% user-supported, users just created the new highway. I was driving in an addition out in Hera this weekend. It was brand new. So I was in my Waze on my phone. I was where there was no road, so I said, pave for new road. I started driving, and my thing turned into a little paver. I drove around the neighborhood. So created the old brand new road for that neighborhood. So it's user-supported. It's really cool. So I get nothing out of telling you that, by the way. It's just really cool to use. W-A-Z-E.
Social GPS, traffic, and gas.
Yeah, because there's gas price there. But the bad thing about it is there's always a bad thing to everything. It uses your GPS. So your battery's going to go dead. It's going to go...
Car charging, all right?
Yeah, I've got a car charger. I left the boat Saturday at 7:40 a.m. with 100% battery. I was surfing the internet, tethering my iPad and using Waze. Not less than 3 hours later, my battery was about dead. So I was using it massively because I was gone for a week. I was downloading all this stuff, but it's kind of cool. If you never play with it, I recommend playing with it. It's kind of cool. And you can update the maps. I can go on the website, here at Rose State. You ever take the road that goes around the campus? You know how there's the neighborhood next to the library? Now you can't go through that neighborhood. Those roads don't connect. But according to Waze, they did connect. So I just went online and said, nope, that road doesn't connect. And no longer, so if you were to drive there now, you'll notice that road no longer connects because it instantly updates the map, which is the best thing. So, all right. I have no idea how I got there, but it's kind of cool. But so parallel backbones is good, but now we're talking twice the cost. Okay. We still kind of have a failure point here. If that router goes out, we still can have an issue. But again, so what do you buy? One extra router? What happens if both routers go out? And actually, for that guy, we actually had a spare router. And what I did was I would take his current configuration, copy it onto his spare router. But then what sucks is anytime you make a change to one router, you got to remember to export it and copy it to the second router. So it's a lot of hassle, but when you need it, it's nice that it's there. Like all this wiring in my house, back when I used a bunch of it, one didn't work, I just plugged it into another one. So it's nice to have extra stuff. But parallel backbone, you got basically duplicate to everything. Okay. We're almost done. Okay. Switching. It says logical network topology. We talked about switches already. It says the connection between the nodes. We have three different types. I think we'll stop after we talk about these. We have circuit switching, packet switching, and multi-protocol label switching. Circuit switching. That's like the old telephones. Anyone still have a home phone? Some of you do. So if you wanted to call someone in Connecticut, like my grandma used to live there, I used to call her on my home phone. It actually created a circuit from my phone at Tinker Air Force Base all the way to my grandma in Connecticut. During that time, that circuit was mine. I mean, some of you are pretty young. Does anyone remember when you called, all circuits are busy now? Does anyone remember that? Some of you older people have gotten that before. I remember when was it 93 tornado came right by Tinker? Trying to call my grandma, even on the cell phone. All circuits are busy now. Oh, crap.
Even your cell phone did that.
Yeah.
Washington, D.C., when 9/11 happened,
Yeah,
it was
killed it.
like 8 hours.
See, the problem is my grandma, she would watch the news all the time. And I knew tornado go through Oklahoma, my grandma was going to know about it. And it came right, bless you, through part of Tinker Air Force Base. She knew I lived on Tinker. I'm like, oh my God, she's going to think I'm dead. So I kept trying to call her, but all circuits are busy now. I'm like, crap.
Where did the 93 one come through at?
It actually came right toward the Sooner Gate. Because I lived right there. I mean, I saw it swirling in my backyard. Then it turned. Then you know where the softball field is now in the corner of Sooner? It's Sooner and 29th. Softball field's there. That used to be horse stables.
That wasn't a 90.
Was it 93?
No, 99.
99, okay.
Thank you. I was like, 93.
99. Okay, whatever one. Well, it took out the horse stables and everything. 93 was the bombing.
Yes.
Or 95. Whatever year.
It's 93.
I don't know. But I still remember getting, all circuits are busy. And I'm like, oh, crap. And the moment I got through to her, finally she's like, oh, so where? I said, I knew you would be. I mean, for some reason, she knew about stuff before I knew about it. It was weird. All right. Now, is that good? Is that a good way of doing stuff?
There's no redundancy. It gets
No redundancy.
overloaded.
How about the I-40? Remember when the boat hit the bridge at the Arkansas River and took out I-40? Does anyone remember that? What happened for the next 6 months? I still can't believe they fixed it that quick, but for the next 6 months, basically, I-40 was missing. So you had to go through Grove, I think it was, or in a couple other places. So it kind of really sucked. So circuit switching, if your circuit gets cut, you're done. And if you have a direct connection somewhere and that's the only way you can go, you're kind of out to lunch. Now, packet switching, a lot better. So we're going to talk about each one of these. So circuit, basically, connection established between two nodes before they transmit. Dedicated bandwidth, a lot more expensive. Okay, it says data follows the same path. So once the connection is made, think back to the old movies where the operator would plug this line into that line. Then that was how it was connected. You had a circuit at that point. So that's the only way it can go. Okay, monopolize it whether you're transmitting or not. Once the circuit's connection, as long as when I used to work at an ISP, we used to sell internet. Sold DSL. We also sold ISDN, Integrated Services Digital Network. ISDN had a longer range, so it could go a lot farther than DSL. We sold, it was like one DSL that was like $40 a month, which was non-dedicated, which means you could not use it 24/7. Could use as long as you needed, but not 24/7. Then we sold a dedicated connection for like $300. So what we would have customers do, they would sign up for the non-dedicated connection. They would connect in the morning, be connected the entire day, then disconnect when they go home at night. So it kind of was breaking the rules. But they really, but they had the connection the entire time. Whether they were using it or not, they'd come on in the morning, they would connect up, and they would stay connected the entire day. So that's what circuit is. Okay? Monopolize the bandwidth the entire time you're connected. Resources are obviously wasted. Okay? Because if you're not using it, why should it still be on? Okay? Could be audio, video teleconferencing, all that kind of stuff. Telephone calls like we talked about. All right, packet switching, so much better. Go to the grocery store. Now I walk through the commissary on Tinker or Walmart, whatever. Take the big cart, fill it up with all my groceries. Then I go to the cashier, and what do they do with it? Other than charge me for it, they put it in separate bags. Can you imagine they put it all in one bag? Walking out the cart, drop it, and replace everything. But now they put it in separate bags. What happens if I drop the bag full of eggs? Replace the eggs. Do I have to replace everything else? No. So what happens is your connection is broken into pieces, and those are sent across the internet. Do they all have to go the same way? No. Could they all go the same way? Yes. But every packet is sent separately, so when it hits the router could actually make a decision. Hey, go this way or go the other way. And as long as they end up at the same place. Okay.
You still talking to them?
I always talk to them. Yeah. I go too many stores. That's why we're behind.
You're what?
Yeah, exactly. And people interrupt me.
Oh, I'm doing what you do to me all the time.
No, get out of here. All right. But they can go on different paths to the destination. They don't have to go the same way. The nice thing about our packets with packet switching is they have sequence numbers. So they get to the other end and it puts it all back in order again. Okay. Okay. Finds the fastest circuit available at that time. Can change. They don't have to follow each other. They don't have to arrive in sequence. They reassemble the destination. Now there is a limit. Say I'm sending 1,000 packets. I mean, I'm not going to wait. I don't know what the limit is, but there comes a point where it can only hold so many packets before it says, hey, I'm missing something. Like one could get lost. It's not going to wait a week for a packet to show up. I don't know the time limit, but there is a certain time limit. Okay? Speedy connections for live audio, video. Okay? It's like Netflix. Can you imagine if we actually had a circuit connection for Netflix? And that means every user for Netflix would have to have their own private dedicated server on Netflix. That would never happen. But our connections are now fast enough. Anyone have any clue how many people watch Netflix at any one time? I've never seen the statistics, but it's got to be millions and millions. Then there's like 6 at my house at one time, every now and then. It's like, geez. The kids will sit there in the bedroom watching Netflix, sitting on the couch with the iPad watching a different show on Netflix. I'm like, what are you doing? Oh, David's watching that one. I'm watching this. And I'm like, oh, give me a break. Drives me crazy. All right. Multi-layer. Okay, this is basically like VPN type stuff. Okay. You could have different stuff, and they can be separated out. I'm trying to think. Can't think of a better example. Because I haven't used anyone that actually used this. Can't think of a good example. Obviously faster connections, but it's kind of like a VPN. So I can't think of a better. Maybe the show is here. They're basically labeling them so you know. Well, okay, we have a switch down the hall that supports labeling. Basically, we can say that these 2 ports have the same label on it. They can communicate faster because they won't interfere with the other ports on it. I can't think of any other way of saying that. Right. It also talks about, you know what quality of service is? Actually, that's something we're going to be implementing here on campus. Like right now on the wireless network, all the traffic is considered equal. Whether you're trying to use it to submit a test on D2L or someone's watching Netflix. It's all the same. But we're going to be upgrading our hardware, actually upgrading the software. The hardware we're already supported. Upgrading our software so we can say, hey, D2L gets a better quality of service than Netflix. So that's what this stuff supports. Where you can make it so certain traffic can get more priority. Kind of understand what I'm talking about? So, and we're going to be implementing that shortly, which will be good. Okay. I think, how many slides are there? Anyone know?
71.
Yeah, let's stop there. Let's pick up on 40 next time. Okay.